Assalamu alaikum everyone, welcome to Exam Essentials. Today we will be discussing the most recent Edexcel IGCSE Further Pure Mathematics Paper 2 question paper. This paper is from June 2025.
This is our question number 1. We can see that we have to solve the equation root 3 into tan A is equal to 2 sine A. The range for A is also given here. In order to solve this equation, we need to bring this equation in a form where we can find the value of single trigonometric functions. We know that when the values of trigonometric functions are given, we can use the sine inverse functions to find the values of the arguments of our trigonometric functions. But when multiple trigonometric functions are given and their values are given, we cannot do the same. We need to simplify these expressions in order to get the single values of the single trigonometric functions. So in order to do that, we need to use identities and many other techniques to simplify these expressions to get the values of single trigonometric functions. In our case, I will first write out our expression. So root 3 tan A is equal to 2 sine A. We know that tan A is equal to sine A divided by cos of A. So here we can replace tan A with sine A divided by cos A. Doing that will give us is equal to 2 sine A. Now I can move the cos A term to the right side. Doing that will give us root 3 sine A is equal to 2 sine A cos of A. Now I can bring all the terms to the left. So root 3 sine A minus 2 sine of A cos of A, and this gives us 0 on the right. From this I can see that in both of these terms sine A factor is present. The sine A factor is present in both of these terms. So I can take sine A common. And this is a very crucial step because this basically solves our equation. So I can write root 3 minus 2 cos A inside our brackets, and this is equal to 0. So from our experience from solving quadratic equations, we know that this term will equal 0 or this term will equal 0. If I simplify this expression, we will get minus 2 cos A is equal to minus root 3, and cos A will be equal to minus root 3 divided by minus 2. So ultimately cos A is equal to root 3. In this expression, we can see that A will be equal to sine inverse 1 of 0. From the question, we already know the range of A. Our value of A exists between 0 and 360. So the range of A is greater than or equal to 0, but less than or equal to 360. Now we already know the standard values for which our sine function is 0. So we can write this out. We know that our sine function is 0 at the angle 0. At 90 degree our sine function is 0. At 180 our sine function is 0. At 360 our sine function is not 0 at 90. Our sine function is 0 at 180. And our sine function is also 0 at 360. And I can go on and on. But I have to realize that our value of A must lie within this range. So the values of the angles that gives us 0 are only 3: 0, 180 and 360 degrees. Now for the next equation, for the second equation, I can write A is equal to cos inverse 1 of root 3 by 2. This will give us a value of 60 degree from our calculator. This will give us a value of 30 degree from our calculator. But this is a basic acute angle. Our angle of 30 degree is a basic acute angle. We know that our cos function is positive in two different quadrants. In the first quadrant, our cos function is positive, and in the fourth quadrant, our cos function is positive. What this means is that any angle in the first quadrant will give a cos value of that is positive, and any angle in the fourth quadrant will give a cos value that is also positive. So in our case, we have an angle of 30 degree, which is in the first quadrant. We have to find out the angle in the fourth quadrant that will also give the same value with the same sign of the value. So we can write, as our value of cos A is greater than 0, is positive basically, our value of A must exist in the first and fourth quadrant. So in order to find the values in the first and the fourth quadrant, the value in the first quadrant is basically is equal to the basic acute angle. The angle in the first quadrant is just the basic acute angle. But in order to find the value in the fourth quadrant, we need to subtract the value of the basic acute angle from 360. So in order to find the fourth quadrant value, I have to do 360 minus 30. I have to subtract the basic acute angle from 360, and this will give us a corresponding angle in the fourth quadrant, and that corresponding angle will give us the same value as our 30 degree angle. So this is ultimately equal to 330. So these are the two values for which our cos is equal to root 3 by 2. The value of our cos function is equal to root 3 by 2 for these two values. So summing up, I can write that A can be equal to 0, 180. Also, it can be equal to 360. I can write chronologically. A is equal to 0, and A can be equal to 30. A can be equal to 180. A can be equal to 330, and A can also be equal to 360. Using any of these values into our equation, into our original equation, will satisfy our equation. The reason these values will satisfy our equation is because they are the solution to this equation. So this was our question number 1, and these are the answers to our question number 1. We can now move on to our question number 2. So this is our question number 2. We can see that in question number 2, we have to find the set of values of x for which our given inequalities are true. So in order to find the set of values that satisfies these inequalities, we need to solve these inequalities. In part A, we are given 9 minus 3x is greater than 11x plus 2. In order to find a solution for this inequality, we need to make x the subject of this inequality. To do that, we need to bring all the x terms in one side and all the number terms or the constant terms to the other side. So we can write 9 minus 2. I'm bringing the plus 2 term to the left, and this will give us 9 minus 2 is greater than 11x plus 3. I'm bringing the minus 3x term to the right. This gives us 9 minus 2, 7 is greater than 11 plus 3, which is 14x. Now I can divide both sides by 14, and that gives me 7 by 14 is greater than x, and x is less than half. Now if I want to write x on the left, I need to flip the equation completely. I need to flip the whole equation, and then I will change the sign, and I will write x is less than half. Notice that the sign of the inequality has changed from this line to this line. The reason for this is we have flipped the whole equation completely. X is on the left side and half is on the right side. That's why we have to change the sign also. So this is the set of values for which our inequality is true. The solution we have is x is less than half. So if we consider any number that is less than half, and then we use that number to find the values for these expressions individually, we will see that the values for these expressions will satisfy this relationship. If x is less than half for every single number where x is less than half, the values for 9 minus 3x will always be greater than the values for 11x plus 2. This range, the values of x in this range will always satisfy this inequality. So this is our answer. This is the set of values of x for which our inequality is true. Now we can move to part B. The inequality in our part B is given as follows: 10x squared plus 7x is less than 12. I can see from here that there are multiple x variables or x terms in our expression. So in order to solve this inequality, we have to notice the power of x. We can see that the highest power of x, the highest power on our variable x is 2. So this gives us an idea that this inequality is a quadratic inequality. In order to solve a quadratic inequality, we need to bring all the terms to the left of the inequality. So this will give us 10x square plus 7x minus 12 on the left side and 0 on the right side. To solve this inequality, we will then try to find the roots for this expression. In order to find the roots, I will equate this expression with 0. I can write for the roots of the equation. For the roots of the expression, we took the expression and we equated the expression with 0. Now I will solve this expression and try to find the values of x for which this expression is equal to 0. So to do that, I can use middle term method. So in order to factorize this expression with middle term, I can write this equation as 10x square plus 15x plus 7x. The plus 7x term can be broken down and written as plus 15x minus 8x, and we can write the rest of the expression. Now I can see that x is common in both of these two terms. In our first two terms, x and 5 is common from both of them, so I can take 5x common. This will give me 2x plus 3 as the expression inside our bracket. Now for the last two term, I can see that 4 is common between them, so I can take minus 4 common from the last two terms. This will give us again 2x plus 3. Now I can write the 2x plus 3 terms together as a single fraction, and I can combine 5x minus 4 into a single fraction. This will be equal to 0. If I clean up the previous steps, this is what we get. So now I can equate the individual terms with 0. So 5x minus 4 is equal to 0. This will give us x is equal to 4 by 5. And the other factor is 2x plus 3 is equal to 0. This will give us 2x equals to minus 3 and x equals to minus 3 by 2. So we now have the two roots of this expression. We now have the two values of x at which our expression will be equal to 0. We can now use these values. We can now use these values of x and the value for the coefficient of x square to draw a rough sketch of our graph. Minus 3 by 2 is the root of the expression. 4 by 5 is another root of the expression. We are drawing the graph for our expression 10x square plus 7x minus 12. We can see that in our expression, the coefficient of x square is 10 and 10 is positive. As our value of the coefficient of x square is positive, our curve will be a minimum curve. Our curve will have a minimum point. So it will be a U-shaped curve. So this gives us a U-shaped curve. From our inequality, I can see that the solution to this inequality is when our expression is less than 0. So from the graph, I can see that when our expression is less than 0, our required region is this. So from this I can deduce that, from this I can say that the region of x minus 3 2 is greater than x and less than 4 by 5. This region of our x gives us the negative values for our expression. So this region will satisfy our inequality. And this is the solution to our inequality in part B. Now for part C, we can see that we have to find a set of values of x. We have to find the set of x values for which both the inequality in part A and the inequality in part B is true. So we have to find a set of value for which both of these inequalities in part A, the one in part A and the one in part B, both of them are true together. So for part C, I can recall that for our first expression 9x minus 9 minus 3x is greater than 11x plus 2. For our first expression, I can say that its solution is x is less than half. This is the solution for our first inequality. For our second inequality, 10x square plus 7x equals to 12 is plus 7x is less than 12. For this inequality, I can say that the solution is minus 3 by 2 is less than x, but x is less than 4 by 5. In order to find a common set of values that satisfies both of these uh, inequalities, I need to draw a number line. On the number line, I can represent the numbers. Now, I will plot the range on our number line. So for our first set of values of x, x is less than half. So our value half lies in this place. So I can say that our range x is less than half is this. Now for the next range, I have to plot 4 by 5 and 3 by 2 on our graph, minus 3 by 2 on our graph. So minus 3 by 2 is equal to minus 1.5. Minus 1.5 lies on here. Now for 4 by 5, we know that 4 by 5 is equal to 0.8. So 4 by 5 will occur here. So this is our range for our part B. From this we can see that the common part in our range, in our both range, is this part. This is the part that is common for both of our ranges. So this is the set of values that will be common for both of them. This is the set of values that will satisfy both of our inequalities. So this will be our answer. So we can write that. So we can write the range of values that will satisfy both our inequality in A and inequality in B will be minus 3 by 2, will be x is greater than minus 3 by 2 but less than half. And this is our answer. We have used the boundary points for our shaded area to find out to write out the range of x from the number line. So this will be our answer to part C. And this concludes our question number 2. Now we can now move to question number 3. So this is our question number 3. We can see that it is given that a plus b root 5 divided by c 6 minus 2 root 5 is equal to 9 plus 4 root 5 divided by c. We can see that in this whole equation we have 3 unknowns, a, b and c. It is given that a, b, c are prime numbers and we have to find the value of a, b and c. Now to solve for a, b and c, we can first simplify the fraction on the left hand side. We can see that the fraction on the left hand side of this equation has an irrational base, has an irrational denominator. So we can rationalize that fraction to simplify this equation further. I can write out the equation. Now in order to rationalize a fraction that has 6 minus 2 root 5 as the denominator, we need to multiply this fraction with 6 plus 2 root 5. So to rationalize this fraction, we need to multiply with 6 plus 2 root 5 divided by 6 plus 2 root 5. The reason why we are multiplying with this fraction is because the value of this fraction is 1. 6 plus 2 root 5 in the numerator and in the denominator cancels out to equal 1. So as we are multiplying by 1, the numerical value of our fraction does not change, but the form of our fraction does indeed change. Our fraction will now turn into a rational function from this irrational form. So now I can multiply the denominators and the bases with each other. And this gives us, when we expand the numerator, we can see that we get 6a plus 2a root 5 plus 6b root 5 plus 2b into 5. This is our expansion for the numerator. In the denominator, we can see that these factors are in the format a minus b and a plus b. So I can apply the formula for a square minus b square here. So I can write that 6 square minus 2 root 5 as a simplified form of our denominator. And this is equal to 9 plus 4 by 5 divided by c. Now I can simplify the numerator. I can write that 6a plus 10b plus 2a plus 6b root 5 is the simplified form of our numerator, and 36 minus 20 will be in our denominator. So we can simplify this to 2 3a plus 5b and a plus 3b. I'm taking 2 common from all the equation, from the whole equation, and in the denominator we have 2 into 8. We see that in this stage we have 36 minus 20, which is 16. I can write 16 as 2 into 8. This allows me to cancel the 2 out from both the denominator and the numerator. Ultimately, I can see that 3a plus 5b and a plus 3b root 5 is the simplified form for the numerator, and 8 is the simplified form of our denominator. And then we have 9 plus 4 by 5 c, 4 root 5 c. From this I can clearly see that 3a plus 5b is equal to 9. We are comparing the sides, we are comparing the coefficients that are in each place respectively. And again, I can write that 3b is equal to 4. I can see from here that c is directly equal to 8 if we compare the sides. Now from these two expressions, I can give this the name of 1, and I can call this equation number 2. So I can use the techniques for solving simultaneous equations to find the value of a and to find the value of b, So I can write that multiplying equation 2 with 3 and subtracting equation 1, we get, so multiplying equation 2 with 3 will give us 3a plus 9b equals to 12. And minus equation 1 will be 3a plus 5b equals to 9. Subtracting this these two equations will cancel out 3a, and 9 minus 5b will give us 4b. So 12 minus 9 would be 3. So we get b is equal to 3 by 4. We can use this to find the value of a. So 3a plus 5 into 3 by 4 is equal to 9, or a is equal to 7 by 4. So these are the two primary values of a and b. We need to put this into our expression, and we need to simplify it to find out the value of a and b. We know that a and b are prime numbers. A, B, C, all of them are prime numbers. So C will also not be equal to 8. Minor correction would be that C is not equal to 8. So now we can input the values of A and the value of B into our expression. The expression was a plus b root 5. So a plus b root 5 will now be, so a plus b root 5 divided by 6 minus 2 root 5 equals to 9 plus 4 root 5 divided by C will now be equal to a equals to 7 by 4 plus 3 by 4 root 5 divided by 6 minus 2 root 5 is equal to 9 plus 4 root 5 divided by C, which in our case is 8. This is not the final value, but this is the intermediate value. Now we can simplify this. We can see that I can take 4 common on our numerator. 1 by 4 is common on our numerator. So 7 by 4, sorry, 7 plus 3, 7 plus 3 root 5 divided by 6 minus 2 root 5 is equal to 9 plus 4 root 5. I can write 8 as 4 into 2. I can see that this 4 and this 4 cancels out, and this then we will have 7 plus 3 root 5 divided by 6 minus 2 root 5 is equal to 9 plus 4 root 5 divided by 2. Now from this I can compare our original equation and I can find out the values of a, b and c. So I will compare this and this to write our final value of a, b and c. We have a equals to 7, b equals to 3, and then we have c equals to 2, and these are the values of a, b and c. So this was our question number 3. We can now move on to question number 2. I'm sorry, question number 4. We can now move to question number 4. So this is question number 4. We can see that we are given a geometric series G that has the first term A and the common ratio R. So we have a series G that has the first term A and we have a common ratio of R that is being multiplied to produce our series. The series will go on like this, and this will form a series. We can see that from our question, we know that the third term of our series is 10 and the seventh term of our series is 40. So we can write the information as follows. We can write U3, which is the representation for our third term. We can write U3 is equal to 10. We can write U7 again, which is the representation for our seventh term. U7 represents the seventh term of our series G is equal to 40. And we are also given that our second term is less than 0, is negative. Now in part A, we have to find the exact value of R. So in part AI, we have to find the exact value of R. At first, we will use the information given in the question. We know that in our series, there are two unknowns. A is an unknown and R is an unknown. Our first term is unknown and the common ratio is also unknown. So in order to find the common ratio R or the exact value of R, we need to have two equations, and then we can use methods for solving the simultaneous equations to solve for A and R. In order to obtain the simultaneous equations, we can use the information given. We know that U3 is equal to 10 and we also know that U7 is equal to 40. If we can recall, the general formula for any term in a geometric series is A R n minus 1. This expression gives the general term of any geometric series. So if we apply this to a specific term, U3 will be equal to A into R to the power of n minus 3. In place of n, we have 3. So 3 minus 1 is 10. Now we can write A R square equals to 10, and this will be one of our equations. We can do the same for U7. I can write U7, I can write the seventh term as A into R 7 minus 1, and this will be equal to 40. I can simplify this as A into R to the power of 6, which again is equal to 40. Now this gives us the two expressions. We can see that in order to solve these equations, we need to use the methods for solving simultaneous equations. We can use substitution to solve these equations. So I can write A equals to 10 by R square. This will be one of our equations that we will substitute in our equation number 2. The reason why we are substituting A is because in part A we have to find the value of R. If we substitute A in terms of R, we will get an expression that contains only our variable R. If an expression only contains our variable R, we can easily find the value of R from that. And when we find the value of R, we will have the answer for part A. So I can substitute our expression from 1 into our expression from 2. This will give us 10 by R square into R to the power of 6 is equal to 40. I can write this can be written as this. R6 by R2 R square is equal to 40. Now, as the bases of this fraction are the same, both have a power of R, so I can simplify this as such. R6 minus 2 equals to 40. This will give us R to the power of 4 is equal to 40 by 10, and R to the power of 4 is equal to 4. I can see that I can write this as R square to the power of square. I can write R to the power of 4 as R square whole square, and I can write
4 as 2 square. From this I can see that r square is equal to 2, and now I can do square root, and this will give us plus minus root 2 for r. From this we see that r is either equal to minus root 2 or plus root 2. In our question we can see that we have to find an exact value of r. So the value of r we need to find is 1. But from our calculation we can see that there are two possible values of r. In order to obtain a single value of r, we need to use another condition, another information given in our question, that the second term of g is negative. We are given that the second term of our term g is negative. So what we can do is we can use each value of r to find the value for our second term. We know that the third term is positive. u3 is positive. So in order for, we also see that our second term is negative. So in order for the u third to be positive, given that the second term is negative, our r must be negative. Let's say our second term is equal to minus 2, and we already know the third term is equal to 10. In order for the third term to be positive, there must be a negative r present. A negative r or negative common ratio must be multiplied with our second term to give us a positive third term. This shows us that our common ratio must be negative. There is no other way for our third term to be positive given that our second term is negative. So that's why the only possible value of r would be negative. So we can write r is equal to minus root 2, and this is our value of r, the exact value of r, and this gives us the answer to part I. For part 2 of a, we have to find the value of a. So we can recall that from our equation 1, we have a is equal to 10 by r square. So I can use this together with the value of r to find the value of a. We know r is equal to minus root 2. So this gives us minus root 2 whole square. So 10 by 2. Ultimately, the value of a is 5. So the value of a is 5. This is our answer to part 2. Now, for part B, we have to explain why g does not have a sum to infinity. We know that in order for a series to have a sum to infinity, it needs to be a geometric series, and it needs to be a convergent series. We already know that our series is a geometric series, so we have to make sure that our series is convergent for it to have a sum to infinity. In order for a series to be convergent, its modulus of r has to be less than 1. Its magnitude of r has to be less than 1. We can see that our value of r is minus root 2. Minus root 2, the magnitude of minus root 2, which is root 2, is greater than 1. So what this shows us is that our series is not convergent, but rather our series is divergent. What this means is that the values of our series increase as the series moves on. In a convergent series, the values decrease as the series moves on. As the series nears infinity, the values of a convergent series become negligible, become extremely small to the point of being negligible. That's why we can find a sum to infinity in convergent series. So in order for a series to be convergent, its common ratio must be less than 1. Its magnitude of common ratio must be less than 1. So in our series G, we can see that our magnitude for our common ratio is not less than 1. Rather, root 2 is greater than 1. That's why we can say that our series is not convergent, and that's why there will be no sum to infinity. We can say that as our common ratio is greater than 1, our series is not convergent. Thus, there would be no sum to infinity. So this was our question number 4, and we can now move on to our question number 5. So this is our question number 5. We can see that in question number 5, we have a triangle ABC where our side AC is equal to 12, BC is equal to 14, and AB is equal to X. And we're also given the angle ABC is equal to 30. In part A, we now have to show that X is equal to
p into root 3 plus minus root 95. So in part A, we have to find the value of AB. We have to find the length of our side AB. We have to find the value of x from our given information. We can also see from the question that x has multiple values. As x is equal to p into root 3 plus minus root 95, we can see that there is two possible values of x. So when we find the value of x from the information given, we will find two different values of x. So I can start solving this. In part A, I have a triangle ABC. Triangle A, B, and C. The angle B is 30 degrees, as given in the question. BC is equal to 14, and AC is equal to 12. And we know that AB is equal to x. As there are two different values for x, as we know from the question, there is two possible values of x. So one of the x can be represented like this, another x would be in extended place, and this will also be 12. So there is two possible values of x. So this is a rough sketch of our triangle ABC. Now from this triangle, I can see that in order to find the value of x, I can use the cosine rule to form an equation using our information given. So I can write by cosine rule, we can write that AC square opposite side squared is equal to the square of the addition of the squares of the adjacent sides. The adjacent sides are AB and AC, minus 2 into AB into AC into cos of angle 30. This is our cosine rule. We can see that using the cosine rule, we can use all the information and we can find an equation that relates all of those equations in a single expression. So this can be used to find out a value for x. So you can use we can now substitute all the values in their respective places. So AC square will be equal to 12 square, AB square is x square, AC square is 14 square, minus 2 into x into 14 into cos of 30. Cos of 30 is equal to root 3 by 2. You can verify it using your calculator. Upon simplifying, we get this. This is our simplified equation. From this equation, we can see that we have two x variables here. And the highest power of 2 in this expression, the highest power of x in this expression is x squared. So from this, we can know that this is an quadratic equation. So in order to find a solution for x, we need to solve this quadratic equation. At first, I will bring all the terms to the left. So 0 is equal to x squared. If I rearrange the terms, so x squared minus 14 root 3 x. I have arranged the terms in ascending powers of x. This will give us 196 minus 144. And this gives us 196 minus 144 will give us 52 as our answer for the C part. Now we can see that we have a quadratic equation. Solving this quadratic equation will give us the value of x. So now if we want to solve this quadratic equation, we know that there are mainly three ways of solving a quadratic equation. One of them is middle term. If we try to factorize this equation by middle term method, we can see that we cannot do that because we cannot break down minus 14 root 3x. We cannot break this down because it is not an integer. It is not an integer value, so we cannot break this down, or we cannot express this this number in terms of the factors of 52. So instead we have to use the quadratic formula to find our value of x. We know that the quadratic formula is equal to plus minus b plus minus root over b square minus 4ac by twice a. From our expression, we know that a is equal to 1. A is the coefficient of x squared, and from an expression we can see that b equals to minus 14 root 3. B is the coefficient of x, so it is equal to minus 14 root 3, and c is 52. C is the constant term of our expression. Now we will input the respective values in the respective places, and this will give us minus of minus 14 root 3 plus minus root over minus 14 root 3 whole square minus 4 into 1 into c. divided by 2 into a. Upon simplifying, we will get 14 root 3 plus, this will give us plus minus root 95 divided by 2. So we can simplify this as 7 root 3 plus minus root 95. So this is our answer. So this is our values of x. We can see our question. In our question we have to show x in this form, and our answer to this is also in this form. So we can say that this is our answer to part A. In part B, we can see that we have to find in centimeter square the difference between the two possible areas of our triangle ABC. We know from part 1 that there are two possible values of the side x, of the side AB. There are two possible values of x. As there are two possible values of our side AB, two possible triangles are possible from these two values of x, and that's why there will be two possible areas. So we need to find the two possible areas, and then we will find the difference between them by subtracting the area of one of them from the other. So for part B, I have to calculate the area for 1x, then I have to calculate the area again for another one. I can say that using x equals to 7 root 3 plus root 95. If I use this value of x and then I try to find the area in our triangle, if x is equal to this value, so our triangle becomes like this. This will be our x, and we have 30 degree here. We know that area of a triangle is equal to half into two adjacent sides. In our case, 7 root 3 plus root 95 into 14. So the area of triangle is equal to two adjacent sides and the angle between the two adjacent sides, which is 30. Sine of the angle between the two adjacent sides. So we have used this side, and we have used the angle between those sides to find our area. And this will give us so this can be further simplified as half into 7 root 3 plus root 95 into 14 into half. Sine 30 is equal to half. Ultimately, this will give us 7 by 2, 7 root 3 plus root 95. This is our area number 1. This is our area 1. Now for our area number 2, the other possible area, we will be using our other value of x. The other value of x is 7 root 3 minus root 95. Using this value, if we find area 2, we can draw an updated drawing. So this is our x, this is our 12 centimeter, this is 14 centimeter, and this is 30 centimeter, 30 degrees. And this is A, C, and this is B. So again, I can see from this triangle that area will be equal to half AB sine theta, or half into x, one of our adjacent sides, into 14, our other adjacent side, and the angle between the two sides, into 14 into sine of 30. The same thing, but with a different value of x. Again, I can use the value of sine 30, which is half, and I simplify this. This will give us 7 by 2, 7 root 3 minus root 95. So these are our area 1 and area 2. So we have to find the difference between them. So the difference between them, D, will be equal to area 1 minus area 2. Subtracting the two areas will give us the difference between the two areas. Area 1 is equal to 7 by 2, 7 root 3 plus root 95. This is the value we got when calculating area 1. Minus our area 2, which is 7 by 2, 7 root 3 minus root 95. Now I can expand the brackets. This will be 7 by 2 into 7 root 3 plus 7 by 2 root 95 minus 7 by 2 into 7 root 3 plus 7 by 2 root 95. We can see from here that 7 by 2 into 7 root 3 is cancelled out. These two terms are cancelled out. So ultimately what we have is 7 by 2 root 95 into 2. We have this term 2 times, so I'm multiplying this term in 2 into 2. So this gives us an answer of root 95. So the difference between the two possible areas is root 95, and this is our answer. The answer will be in centimeter square. we can read that we have to give our answer in the form m into root n, where m is a prime number and n is an integer. And this is what we have here. Our m is 7, which is a prime number, and then we have a 90 n as 95, which is not a prime number, but which is an integer. It is an integer. So this is our answer for part B of question number 5. And this concludes our question number 5. We can now move on to question number 6. So this is our question number 6. We can see that we have a figure of a cylinder, and the radius of the cylinder is r centimeters, and the height of the cylinder is h centimeter. If you read the question, we can see that in figure 1, a right circular cylinder with radius r and height of h is shown. The total surface area of the cylinder is 700 pi centimeter square. So the total surface area of the whole cylinder is 700 pi. What is meant by the total surface area is the sum of all the individual areas of all the faces. So the circle on the top, the area of the circle on the top, the area of the circle on the bottom, and the area of the curved surface of the cylinder, they all add together, and they will equal 700 pi. Now, it is also said that the volume of the cylinder is V centimeter cube. In part A, we have to show that V is equal to pi r into 350 minus r square. So we have to find an expression for our volume in terms of r, the radius. Typically, we know that the volume of a cylinder is equal to we know that the volume of a cylinder or any prism in general is the area of its cross section into its length. In case of our cylinder, the area of our cross section is the area of a circle, and the length is our height. So the volume of a cylinder is pi r square h. We know that. But in our question, we can see that the expression of volume does not have the h term. What this shows us is that we have to substitute the value of h, and we have to find an expression in terms of r. In order to find an expression for h in terms of r, we will use the value of total surface area. So let us start solving. In part A, we can use the information given in our question that total surface area is equal to 700 pi, where T represents our total surface area. Now we know that total surface area of a cylinder will be equal to the area of the two circular faces, so pi r square plus pi r square, and the area of the curved surface of the cylinder, which is equal to 2 pi r h. 2 pi r h. This is equal to 700 pi. So the total surface area of a cylinder is equal to 2 pi r square plus 2 pi r h. This is also usually written as 2 pi r plus h. There are many forms in which this is written. So now from this expression, I can now make h the subject of this expression, and this will give us an expression of h in terms of the radius r. And we can then use this expression to substitute h in our expression of volume. So in order to make h the subject of the formula, I can rearrange and write 700 minus 2 pi r square is equal to 2 pi r h. 2 pi r square terms moves to the right. Then I can write h is equal to 700 pi divided by 2 pi r minus 2 pi r square divided by 2 pi r. What happened here is we divided both sides by 2 pi r. Both sides are divided by 2 pi r. Now if we simplify, we get 350 divided by r minus r. So this is our expression for h. We know that the volume of a cylinder is equal to pi r square h. The reason the volume is equal to pi r square h is because the cross-sectional area of a cylinder is a circle, which is pi r. So the area of a cylinder is pi r square, and the length of a cylinder is its height. So we are multiplying the cross-sectional area pi r square with its length, or h. So this will give us the volume of the cylinder. Now we are substituting h into our expression for volume. We can move on to the next page and write this. So we are substituting our expression I into our expression for volume. volume is equal to pi r square h. So pi r square, and we already have seen that h is equal to 350 by r minus r. Now expanding the brackets will give us pi r square into 350 divided by r minus pi r cube. So cancelling out r from both sides, sorry, cancelling out the r in this term, we get that 350 pi r minus pi r cubed is our expression for volume. We can see that pi r is common in both of the terms. The factor pi r is common in both of the terms. So I can take pi r common, and this will give us 350 minus r square into our brackets. If we now see the question, we can see that we have shown this expression here. So our part A is done. This is our answer to part A. For our part B, it is given that r can vary. So it is said that the radius of our cylinder can vary. From this expression, we can see that if our radius varies, our volume will also vary, because volume is dependent on our value of r. Now in part B, it is given that r can vary, and we have to use calculus to find the value of r for which v is maximum. In part B, we can recall our expression from part A. We can see that this is an expression in terms of r. And in order to find the maximum value of v, in order to find the maximum radius, the radius that gives the maximum value of v, we need to differentiate this equation and equate the differentiation with 0. So at first I will do differentiation. Our expression can be simplified as this. Now we can differentiate this expression. Differentiating two terms is equal to differentiating them individually. So I'm writing the terms out individually. I'm differentiating them individually. So this will give us 350 pi minus pi into 3r square. So 350 pi minus 3 pi r square. And this is our differentiation. We know that when v is maximum, we know from the general property of functions that when a function is at its maximum value, its dy by dx or its gradient will be equal to 0. So when v is maximum, dv by dr will be equal to 0. Its gradient will be equal to 0. We know that from the general property of functions. So we can use this property to find our value of r. Then I can write 3r square is equal to 350 pi divided by 3 pi. This can be simplified. Now r will be equal to root over 350 divided by 3. And this will give us 10.801 from the calculator, and we have to write our value of r in 3 significant figures. And we know this from our question. In our question, we have to find in centimeter the in 3 significant figures. So we have to write our answer in 3 significant figures. And we've written our answer in 3 significant figures. So this is a part of our answer. Now, it is also said that we have to justify that this value of r gives a maximum value of v. We know that functions can have minimum points and maximum points. Both of these points will have a gradient of 0. Both of these points, the maximum point and the minimum point, will have a dv by dr, or will have a dy by dx of 0. So when we are finding out the value of r using dv by dr equals to 0, we are not sure whether or not this value gives us a maximum value or a minimum value. That's why in order to be sure that this value is indeed maximum, we need to find out the second derivative of this function, which is d square by dr square of v. So I can write that d square by dr square of v will be equal to ddr of 350 pi minus 3 pi r square. Differentiating the already differentiated function will give us the double differentiation for v, the second derivative for v. So this will be equal to This will be equal to dr. Again, I can differentiate the terms separately. This gives us differentiation of a constant term is equal to 0. And differentiating this term will give us 3 pi into 2r. So minus 6 pi r is our second derivative or our double differentiation. Now, inputting our value of x into our expression for d square by dr square can help us find out whether or not the point is maximum or minimum. So at r equals to 10.801, I'm using the more accurate value, not the rounded value, for increased accuracy. Now this is equal to, we can already see that this is a negative value. I'm still going to calculate this, and this gives us minus 200. We can see that this value is negative, which means that every other point beyond our r equals to 10 will have a lower value for v, which means that r equals to 10.8 gives a maximum value. As the value for the second derivative, as the value for d square divided by dr square v is negative, we can say that r equals to 10.8 will give a maximum point for v. You can say it gives us a maximum value of v. Maximum value of v. And this is our answer to our b number b part. In part C, we have to find three significant figures, the height 8 cm for which v is maximum. We already know the value of r. We already know the value of r at which v is maximum. So we can use the value of r to calculate the value of h for which our v will be maximum. So we can write that in part C. We know that h is equal to 350 divided by r. The expression was something like this: 350 divided by r minus r. So h is equal to 350 divided by r minus r. Now I can use the value for r. Again, I'm going to use a more accurate value for r in order for greater accuracy. Now this will be equal to 21.6. And this is our answer for our height. So this was our question number 6. Now we can move on to question number 7.
So this is our question number 7. We can see that in part A, we have to complete the table of values for our equation y equals to log 3, 4 minus x plus 3. And we have to give our answers to two decimal places. So we have to complete the table of values for this equation. We can see that many values of x are given, and we need to use the equation to find the value of y. So in order to find the values of y, I will input the values of x into our expression. So for x equals to 0.5, we will input 4 minus 0.5 plus 3. For x equals to 1.5, we will input 1.5 instead of x. So this is how we will calculate the values. Doing that will give us minus 0.5 plus 3. This is equal to 4.14. 1.5 is equal to 3.83. We are keeping all the values to two decimal places as given in our question. For 2.5, we have 3.37. So this is our part A. We completed our table. Now for part B, we can see that we have to draw the graph of y equals to log 3, 4 minus x plus 3 in this interval. We have to draw our graph in this grid, the given grid. So we can see that we know some points of x, and we know the corresponding values of y. So we know the coordinates of various points on our curve. We know the points that lie on our graph.
So we can plot these points and we can join the points to form the graph of this function. So I can start plotting. First coordinate is 0, 4.26. So x is equal to 0 and y is equal to 4.26. X is equal to 0 and 4 and y is equal to 4.26. We can see that there are 10 boxes between 5 and 4. So each boxes represent 0.1 units. So 4.26 would be here. Then we have 0.5, 4.14. Again, in our x-axis, we have 10 units between 1 and 0. So each unit represents 0.1 units. So 0.5 x equals to 0.5 and y equals to 4.14 would be here. Then the point 14 would be here. Then the point 1.5, 3.83 would be here. 1.5 and 3.83. So we can plot the point at 3.8. Then we have to 3.63. So we can plot the point at 3.6 to 3.6. And then we have 2.5, 3.37. So we can plot this point at 3.4. So 2.5, 3.37. So 3.4. I can plot the point at 3.4. And then we have 3 and 3 and 3.5 and 2.37. For 3.5 we have 2.4. 3.5 we have 2.4. So joining all the points will give us the graph of y equals to log 3, 4 minus x plus 3. So we have joined our points to form a smooth curve in our intervals 0 and 3.5. So this is our answer to part B. So now for part C, we can see that we have to draw a suitable straight line on the grid to obtain an estimate for the root of the equation, for the solution of this equation. So in order to find the solution for this equation, I can simplify this expression. We have the expression 3 to the power of 2x minus 5 minus 4 minus x cube is equal to 0. We can write this as 3 2x minus 5 equals to 4 minus x to the power of cube. Now I can log on both sides. I can take log for both our left hand side and right hand side. Doing that will give us, so taking log of base 3 on both sides, we will get 2x minus 5 log 3 and 3, and we will get 3 log of 4x minus 5, 4 minus x in brackets. Now this can be written as 2x minus 5 equals to 3 log 4 minus x, log 3 4 minus x. And from this we can see that in order to form the equation here in our equation, if we want to bring our equation here, we have to bring the term log 3 4 minus x plus 3 onto our right hand side. So in order to bring that format on our right hand side, I can divide both sides by 3, and this will give us log 3 of 4 minus x
and then I can add 3 on both sides. Doing this gives us the exact format as given in our question, log 3 4 minus x plus 3. So I can now say that the solution for our original equation will be the solution for 2x minus 5 divided by 3 plus 3 and our graph of y. From this we can see that the intersection point between this curve and this curve will give us the points for which this equation is equal to 0. So basically the solution of this equation, the intersection point between these two curves will give us the solution to our original equation. So we can say that y equals to we can say that y equals to 2x minus 5 divided by 3 plus 3 is our suitable line. I can just simplify this a bit. So making it in a single fraction will give us 2x minus 5 plus 3 3 are 9. So 2x plus 4 by 3 is our suitable line. This is our suitable line. So drawing this line in our graph will give us an intersection point for the graph, and from there I can say that the solution of equation would be the intersection point. So in order to draw this line, I can find out two different points on this graph. So let's say we can consider x equals to 0. In order to draw this graph, this is a straight line. This is a graph of a straight line. That's why if we want to draw the graph of a straight line, we need 2 points. If we have 2 points, we can join the points and form the line. So I'm taking 2 points. I will choose any. We can choose any values to find out the 2 points. So at x equals to 0, I can say that y would be equal to 2 into 0 plus 4 by 3, and this will be equal to 4 by 3. Ultimately, which is equal to 1.33 something. And at x is equal to, let's say, we can say 1. At x is equal to 1, y is equal to 2 into 1 plus 4 divided by 3, and this will give us 6 by 3, which is equal to 2. So these are the 2 points. X equals to 0, y equals to 1.33 is one of our points, and x equals to 1 and y equals to 2 is another point. So we can plot these points on our graph, and then we can find the intersection point by seeing the coordinates of the intersection point. So I will plot the points. At 0 it is 1.33. The value of our straight line is 0 is 1.33 at 0 at x equals to 0. So it's 0 1.33. So we have this as our point, and then we have 1 2 as our another point. So 1 and 2 is the other point. Now I can draw a straight line through this. And this is our straight line. From this I can see that there is an intersection point between the graph and our straight line. That intersection point will give us the solution to this equation, the solution to this whole equation given in our question. So in order to find the values of x for which this expression is equal to 0, or in order to find the solution of this equation, I will just read the intersection point from the graph. We just need to read the intersection point from the graph. What we can do, we can mark the intersection point, and we can see what it reads from our axis. This is usually represented with a broken line. So if we read from our axis, we can see that our the x coordinate of intersection point is 2.65. So we can write that our solution is x equals to 2.7. So we can say that the solution to our equation, is x equals to 2.7. The answer will vary depending on the graph you draw. So from my graph I can get the value of 2.65. From your graph it may differ. So this is our value. This is our solution. So this concludes our question number 7. And we can now move to our question number 8. this is our question number 8. We can see that we have a figure of a triangle OAB, and we have OA as a vector, expressed as a vector. We have the side OA expressed as a vector 3u plus v, and OB is the vector minus u plus 2v. In part A, I have to find AB vector as a simplified expression in terms of u and v. So I have to find AB vector in terms of u and v. So to do that, I can write that AB vector is equal to AO vector plus OB vector. I can write the AO vector as minus OA vector. The reason I can write it like this is because the AO vector is just the opposite opposite in direction of OA vector, or the OA vector is just opposite in direction of the AO vector. The lengths, their lengths and direction are the same, but their direction is just different. They're just opposite in direction. That's why I can express AO vector as minus OA vector. I can see this from our triangle. I can see that the vector OA is just opposite in direction with the vector AO. So now writing this makes our calculation easier. So now I can write that minus, we know that OA vector is equal to 3u plus v. So I can write minus 3u vector plus v vector plus OB vector is equal to minus u plus 2v. So I can write plus minus u plus 2v. Now I can expand, and this gives us this expression. I can just simplify this to get our final value for AB. So minus 4u minus v, plus v. So this is our expression for AB. This is our expression for AB vector. AB vector is equal to minus 4u vectors plus v vector. Now we can move to part B. We can see in part B, a point C is given such that AC is parallel to OB. There is a point C around our triangle that makes the vector AC parallel to vector OB. So there is a point C that makes the length AC parallel to the length OB. So these two are parallel. This line and this line is parallel. Now the further equation that is given is that OC is equal to mu v. So the vector OC is equal to mu v. Now in part B, we have to find the value of mu. So it is given that OC vector is equal to mu v vector. We have to find the value of mu. From this, we can see that we know the vector OA, and we can know the vector AC. As the vector AC is parallel to the line segment OB, we can write that that AC vector will also be parallel to OB vector. What this means is that AC vector can be written as this. If we can express AC vector as such, we already know the vector OB, we already know the vector OA, so we can use those values to find a value for OC. So in part B, I can express AC vector as lambda AB, as AC and as lambda OB. We already know that the AC vector and OB vector are parallel. As they are parallel, their direction is the same. The only way they differ is by their magnitude. That's why I can write AC vector is equal to lambda, which is a scalar quantity, into our OB vector. If I simplify this, I know that OB vector is equal to minus u vector plus 2v vector. So this will give me minus lambda u plus 2 lambda v for the vector AC. From our triangle, I can see that OC is equal to OA plus AC. Our OC vector is equal to OA plus AC. From our given information, we know that OC is equal to mu v vectors and OA is equal to 3u plus v vector. And we have already calculated the value of AC in terms of lambda. So minus lambda u plus 2 lambda v. We can now simplify this. So 3u minus lambda u plus v plus 2 lambda v equals to mu v.
I can write mu v as 0 u vector plus mu v vector. I can write the left hand side like this. The reason we're writing like this will be clear in just a moment. So if I simplify the left hand side, I can write 3 minus lambda u vector plus 2 lambda plus 1 v vector. Now we can see that we have the u vector and the v vector in both sides of our equation. So we can now compare the equation. We can now compare the sides. After comparing, we can see that 0 is equal to 3 minus lambda and 2 lambda plus 1 is equal to mu. From this expression, I can easily find out the value of lambda. So lambda will be equal to 3. So now I know the value of lambda. I can use this value of lambda into this equation to find the value of mu. So mu will be equal to 2 into 3 plus 1. 6 plus 1 is 7. So mu is equal to 7. So we have calculated the value of mu. So for part C, we read that lines OC and AB intersect at point X. So lines OC and OB, they intersect at point X, which I've marked here. The lines AB and OC, they intersect at point X. And it is also given that point D lies on OC, such that the area of the triangle BOS is to the area of the triangle BXD is equal to 2:3. So we are given the ratio of this area, the area of our triangle BOS, and this area, the area of the triangle BXD, and D lies on our line C. D lies on our line C. Now with this information, we have to find an expression for BD. We can find an expression for BD. Now in order to find an expression for BD, I will have to first find an expression for OX. I can see from the diagram itself that OX lies on OC. That's why OX is parallel to OC. So I can express OX as a constant, as KOC, with a constant into OC. Because as these two are parallel, I can write OX like this. I already know from our part B that OC will be equal to mu V. So mu is 7, so OC will be equal to 7V. I know from our part A that OC is equal to 7V vector. So our OX is equal to 7KV vector. We also see from this diagram that OX can be calculated using the expression OA plus AX. Notice that we do not have a value for AX, but again we can assume that AX is equal to a constant into AB vector. The reason we can assume this is because X lies on our line AB and AX is parallel to our vector AB. That's why I can express AX as such. So I can find the value of OX from this. I can write OA plus M into AB, and simplifying this, I will get an expression for OX in terms of M, and on the left hand side, I will get on the left hand side I will get an expression for OX using K. So I can compare these two expressions the left hand side and the right hand side, to find out the value of OX. This is the same exact process as our part A. As our part B. This process is the same exact process as our part B. So I can start doing this. So for C, I know that OX is parallel to OC. So I can express OX as KOC with a constant. I also know that OX can be expressed using the vector sum of OA and AX. From our diagram, I can clearly see that AX is parallel to AB, which means that I can express AX using a constant into our vector AB. Simplifying this will give us, we know that the AB vector is equal to minus U plus V vector. So from this I can write M into minus U. Our AB vector is equal to minus 4U plus V. So I can write this in place of AB vector. So minus 4U plus V, and this gives us minus 4MU plus MV as our AX vector. I know the value of OX from our expression, from our equation, 3U plus V. OA is equal to 3U plus V. So 3U plus V plus AX, and AX is equal to minus 4MU plus MV. Simplifying this, we get minus 4MU plus MV, and if I add the coefficients of U vector and V vectors together, This gives us this. I can now take this expression and write it here. So OC is equal to K into 7V, or 7kV is our expression for OX. So I can write 7kV on our right hand side. I can express 7kV as 0 into U vector plus 7k into V vector. Now comparing the two sides, I can clearly see that 0 is equal to 3 minus 4m. The coefficient of U are equal and the coefficients of V is equal. So 7k is equal to 1 plus m. From our first equation, I can easily find out the value of m. I can say that 4m is equal to 3, or m is equal to 3 by 4. I can use this value of m into our second equation. So 7k equals to 1 plus 3 by 4, or k will be equal to 7 by 4 divided by 7. So 1 by 4. K is equal to 1 by 4. From this I can find the value of OX. I know that OX is equal to 7kV. K is equal to 1 by 4. So OX is equal to 7 by 4 V. 7 by 4 V. So from here I can see that we know the value of OX. In order to find the value of BD, in order to find the value of BD vector, I need to know another vector. If as we know the vector OX, I can try and find the vector OD. If I try to find the vector OD, I can use the vector OB to find the vector of BD. We know that BD is equal to BO and OD. So if we use the vector OB and use the vector OD, we can find the vector BD. So if we find the value of OD, we can easily find the value of BD. To find OD, we can use the other information given in our question number B. Sorry, part C. In part C, we have lines OC and AB intersect at point X, and the area of the triangle BOX is to the area of the triangle BXD is equal to 2:3. So we can write this is from our question. We can write this from our question. If I draw the triangle again here, we have this arrangement in our figure. So we have BOX, this is our point B, this is our point X, this is our point D, and this is our point O. So we have BOX and BXD. We have the area ratio of BOX and BXD. And this gives us 2 by 3. We can see that in these two triangles have a common base and they have the same last point. So their height will be the same. The height of the triangle BOX and the triangle BXD is the same. So that's why we can write that of triangle BOX and triangle BXD are same. If we know this, we can now write the triangle area of the triangle BOX divided by area of the triangle BXD. We know this is equal to 2 by 3. We can write that the area of the triangle BOX would be equal to half into the base of the triangle BOX into its height. So the base of the triangle BOX is OX. So half into OX into height divided by half into the base of the triangle BXD into its height. So the base of the triangle BXD is XD. So half into XD into height, which is H. And this is equal to 2 by 3. From this, we can clearly see that I can cancel out half. I can cancel out H. So what we are left with is a ratio of OX and XD. From this ratio, I can find out the ratio of OX with OD. We know that OX is to XD is equal to 2 by 3. Is equal to 2:3. So I can write OX x to OC would be equal to OX is to XD plus OX, which is now equal to 2 is to 3 plus 2. OC can be written as XD plus OX. So I'm substituting the values of XD and OX into our ratio, and this gives us 2:5. So what we see from here is that, I'm sorry, this is OD. what we see from here that the ratio of OX and the with OD is equal to 2:5. So OD will be equal to 5 by 2 OX. So the vector OD will be equal to 5 by 2 into our OX vector. Now this is equal to 7 by 4 V. Now upon simplifying we get 35 by 8 by V. So this is our vector OD. Now from this I can easily find out the vector BD. To find the vector BD, I have to add the vector BO with the vector OD. I know that the vector BO is just the negative of our vector OB. So I can express vector BO as minus OB. And then I can add OD. Now OB is equal to minus U plus 2V as given in our question. OB is equal to minus U plus 2V. So minus of minus U plus 2V plus OD. OD we know is equal to 35 by 8V. Now simplifying this will give us 35 divided by 8 minus 2. And this gives us U minus 19 by 8V. This is our BD vector, simplified in its simplest form. So this is our answer to our part C. And this completes our question number 8. We can now move to our next question. Question number 9. So this is our question number 9. We can see that in our question we have an equation y equals to e to the power of minus 40 into cos 2t. In part A, we have to show that 2 into e to the power of minus 40 into sine 2t is equal to minus dy by dt minus 4y. So in order to show this, I can use the right hand side of this equation, and I can input the respective expressions for dy by dt and y into our expressions, and then I can simplify to show that our right hand side is equal to left hand side. So for this expression, for part A, I will use the right hand side, the RHS, which is dy by dt minus 4y. If I use the expressions for dy by dt in our equation, in our question, and the expression for y, and then I simplify, we will get the value 2 into e to the power of minus 40 into sine 2t, and that will prove that our RHS, our left hand side, is equal to right hand side, and we would have shown this expression. So so we need to find the expression for dy by dt, and then we can use the expression and the expression of y to simplify this expression. We know that y is equal to e to the power of minus 40 into sine into cos of 2t. Dy by dt for this expression would be d dt of e minus 40 into cos 2t. We can see that we cannot further simplify this expression. This expression cannot be further simplified. That's why what we need to do is we need to differentiate this using the product rule for differentiation. The product rule for differentiation states that we need to take the first term and we need to multiply it with the differentiation of the second term. So we take the first term, then we multiply it with the differentiation of the second term. Then we take the second term and we multiply it with the differentiation of the first term. The first term is e to the power of minus 40. Now simplifying this, we get e to the power of minus 40 into the differentiation of cos 2t. We know that the differentiation of cos 2t will be equal to minus sine 2t into the differentiation of 2t. The reason why we need to multiply this term is because we are doing the chain rule for finding out the differentiation of cos 2t. We know that the differentiation of cos t will be minus sine t, but we have cos 2t. That's why in order to differentiate this, we are differentiating with respect to 2t, and then we are differentiating 2t according to the chain rule. So I can write that the differentiation of cos 2t is equal to minus sine 2t into 2, because the differentiation of 2t is equal to 2. Now again I can write cos 2t into the differentiation of e to the power of minus 40. We know that the differentiation of ex is e to the power of x. Following that logic, following this information, we can see that e to the power of minus 40 should be equals to e to the power of minus 40. But as we can see that we are assuming 40 as x, we need to differentiate minus 40 and we need to multiply it with our expression. So we need to multiply the differentiation of minus 40 with it. Again, this is according to the chain rule for differentiation. Simplifying this, we get minus 4 e to the power of minus 40 into minus 4 e to the power of minus 40 minus 2. We simplifying our first term, we get minus 2 e to the power of minus 40 sine 2t, and then we have minus 4 e to the power of minus 40 cos 2t. Now there is no further way of simplifying this expression, so our expression for dy by dt is equal to this. Now I can use this expression for dy by dt, and I can substitute this expression into the right hand side of our given expression in part A. We know that the right hand side was equal to minus dy by dt minus 4y. Let me check again. Yes, this was the right hand side. So this will be now equal to minus dy by dt is equal to this expression, minus 2 e to the power of minus 40 into sine 2t minus 4 e to the power of minus 40 into cos 2t, and minus 4y would be equal to, we know that y is equal to e to the power of minus 40 into cos 2t from our equation. From our equation we know this. Upon further simplifying, I can expand the brackets, and this will give us positive 2 into e to the power of minus 40 into sine 2t, and plus 4 e to the power of minus 4 t cos 2t minus 4 e to the power of 40 minus 40 cos 2t. I can see that this term and this term is the same term, and they are, so we can cancel them out because one of them is positive and one of them is negative. We can cancel them out, and our right hand side is equal to e to the power of 2 into e to the power of minus 40 sine 2t. So from this we can see that our right hand side is equal to our left hand side. So we can say that we have shown this expression is true. So we can write shown. This is our part A. For part B, we can see that it is given that the double differentiation of y plus m into dy by dt plus ny is equal to 0. It is already given. Now we need to find the value of m and we need to find the value of n. We can see that in this equation, we need to use the expression for dy by dt, and we need to also use the expression for y. We already know the values for these expressions. We already know the expressions for this, but we do not know the expression for this term, the double differentiation. So we are going to double differentiate our dy by dt term from our part A. So for part B, I can write that the dy by dt square of our expression would be d dt of minus 2 e to the power of minus 40 sine 2t minus of 4 e to the power of minus 40 cos 2t. So differentiating this means that we need to differentiate this term and this term separately. Doing that, we have to apply the product rule for both of this term, and that will give us, we know that we need to apply the differentiation for both of the terms. So minus 2 e to the power of minus 40 sine 2t minus of d dt of 4e minus 40 cos 2t. Notice that we already know the differentiation for this term. We've already differentiated our y. This term is just 4 times into y. So we can use the differentiation from our part A to write down the differentiation for this term. Before that, I need to find out the differentiation for this term. So for this term, we have to apply the product rule. Using the rules for product rule, we have to first take the first term and we multiply the differentiation of the second term with the first term. So the differentiation of the second term would be d dt of sine 2t. Then I will add the second term with the differentiation of the first term. This will be in a bracket, and there will be the our known differentiation minus 40 cos 2. I've written this term so that I've written this term like this so that I can write out the differentiation for this from part A. Now simplifying our expressions give us minus 2 e to the power of minus 40 into ddt of sine 2t. We know that the differentiation of sine 2t will be equal to cos 2t into 2. So I can write minus 2 e to the power of minus 40 into cos 2t into 2 plus sine 2t into the differentiation of minus 2 e to the power of minus 40, or which is equal to minus 4 into minus 4. So e to the power of minus 40 into minus 4 is the differentiation for minus e to the power of 40. This is for the differentiation of term number, our term 1. For the other term, the term we know the differentiation of, we can write that the differentiation of this term is the same as our part 1. In part 1 we differentiated and we got this answer. So I can just write it out, minus 2e minus 4t sine 2t minus 4 e to the power of minus 4 e to the power of minus 40 into cos 2t. Again I can simplify. So minus 4 e to the power of minus 4t gives us cos 2t plus 4 to the 8 e to the power of minus 40 sine 2t. And on the other side, on the other term, we have minus 4 plus 8 e minus 40 sine 2t, and we have plus 16 e minus 40 cos twice t. Simplifying this expression will give us, we know that we can see from here that some terms are similar to each other. So this term is similar to this term, and this term is equal to this, is similar to this term. So I can say I can add the like terms. I can add the same terms together. So 16 minus 4 will give us 12. 12e minus 40 cos 2t plus 16 e minus 40 sine 2t. These are the simplified expression for the double differentiation of y. We know from the question that we have to show that this equation, we know that this equation is equal to 0, and we now have to find the value of m and n from this. So I can substitute the values, the expressions for the double differentiation of y, the dy by dx, dy by dt of y, and the value of, and the expression for y, and then I can find out the value of m. So I can write d square by dt square y plus m dy by dt plus ny is equal to 0. So I can input the expressions in this in this equation. So 12 minus e to the power of 4, 40 cos 2t plus 16 e minus 4t sine 2t plus m into dy by dt. Dy by dt is equal to minus 2 e to the power of minus 40 sine 2t minus 4 e to the power of minus 40 cos 2t plus ny. Now y is equal to e to the power of minus 40 into cos 2t. E to the power of minus 40 into cos 2t. And this is equal to 0. Now we can just simplify. We can just simplify this. We can write that 12 e minus 4 t cos 2t plus 16 e minus 4t sine 2t, and if we expand the brackets with m, we get minus 2m e to the power of minus 40 sine 2t minus of 4 m e to the power of minus 40 cos 2t plus n e to the power of minus 40 cos 2t. I can now add all the coefficients for the same terms together. I can see that this term, and this term are similar terms. So I can add the coefficients for them. So I can write that 12 minus 4m plus n e to the power of minus 40 cos 2t and I can see that this term is similar. So plus 16 minus twice m e to the power of minus 4t sine 2t is equal to 0. Now, as both of these terms are as the summation of both of these terms are 0, from this we can say that 12 minus 4m plus n is equal to 0, or 16 minus 2m is equal to 0. Now from this equation, I can just change the subject. I can just make m the subject of this expression, and I can find the value of m. So m is equal to 16 by 2, or 8. I can now use this value of m in our first equation. So 12 minus 4 into 8 plus n is equal to 0, and 12 minus 4 into 8 will give us 32, minus 32 plus n is equal to 0, and n is equal to 20. So this is our answer to part B. We have to find the value of m, and we have to find the value of n, and we have done that. So m is equal to 8, and n is equal to 20. And this is our answer. So this concludes our question number 9. We can now move on to our question number 10. So this is our question number 10. We can see that in question number 10 we have a curve C that has an equation of y equals to 7 minus x divided by 2x plus 3. Now in part A, we can see that we have to write down an equation of the asymptote to C. We have to write down the equations of asymptote to our curve C. In part 1, we have to write down the asymptote that is parallel to the y-axis. We know that the asymptote that is parallel to the y-axis is the vertical asymptote. In order to find the equation of the vertical asymptote, we have to find the value of x for which our denominator is equal to 0. The denominator in our expression is 2x plus 3. The expression in the bottom part of the fraction is 2x plus 3. So if we find the value of x for which this expression is equal to 0, we will find out the vertical asymptote, or we will find out the asymptote that is parallel to the y-axis. So from this we get x equals to minus 3 by 2. So x equals to minus 3 by 2 is our vertical asymptote. For our part 2 of part A, number 2 of A, we have parallel to the x-axis. So we have to find the equation of the asymptote that is parallel to the x-axis. We know that the asymptote that is parallel to the x-axis is the horizontal asymptote. To find an equation of the horizontal asymptote, we have to take the coefficient of x from the numerator, and we have to take the coefficient of x from the denominator, and we have to divide them. We can see that the coefficient of x in our numerator is minus 1, and the coefficient of x in our denominator is 2. So I will divide minus 1 by 2. So minus 1 by 2 gives us a coefficient of asymptote of y equals to minus 2. So these are our two asymptotes. X equals to minus 3 by 2 and y equals to minus half is our asymptotes. Now for part B, we have to find the coordinates of the point of intersection of C with the x with the coordinate axis. So for part B, we have to find the values. We have to find the points at which our curve crosses the x-axis and the y-axis. In order to find the coordinates of those points, for the crossing points at x-axis, we can write that at x-axis we know that y equals to 0. So if I substitute y equals to 0 into our expression, we get 0 equals to 7 minus x divided by 2x plus 3. So 7 minus x is equal to 0, or x is equal to 7. From this we can see that 7, 0 is the crossing point of our curve in the x-axis. For the y-axis, we can write that at y-axis x is equal to 0. So y is equal to 7 minus 0. We are substituting x equals to 0 in our expression, divided by 2 into 0 plus 3. Ultimately this gives us 7 by 3. So from this we see that 0, 7 by 3 is the crossing point at y-axis, is the point at which our curve crosses the y-axis. In part C, we can see that we have to use the x-axis given on the opposite page, and we have to sketch our curve C. We have to clearly show the equations of the asymptotes, and we also have to show the coordinates of the points where C crosses the coordinate axis. So in order to draw our curve C, I will first draw out the asymptotes for this graph. So here we can see that I've added markings to our axis, and I've plotted the asymptotes. So the horizontal asymptote is y equals to minus half, and the vertical asymptote is x is equal to minus 3/2. Now I will plot the intersection points. One of our intersection points, it is at 7, 0, so this point, and one of our other intersection point is at 0, 7/3. 7/3 is equal to 1.33. So this is our intersection point. So these are the two intersection points with our coordinate axes, and we have shown this. Minor correction, we have 0, 7/3 as our point on our y-axis. So this will be 2.33. So our point will be here. So this is the intersection points with the coordinate axes. So we have the asymptotes, we have the coordinate points with the coordinate axes, and now we can draw the graph. So this will be a graph. This will be the graph for our function. It will have asymptotes on both of these points, and the graph will be like this. So we can now move on to our part C. Part D, I'm sorry. So in part D, we have an additional information. The C passes through the point A with coordinates half and 13/8. So we have a point A with coordinates this, and the point and our curve C passes through this point. In part D, we have to show that the gradient of C at our point A is minus 17/16. In order to show that the gradient at point A is this, we need to find an expression for dy by dx. We know that the dy by dx gives us an expression for the gradient of our curve at any value of x. So we can use the value of point A to find the gradient at point A if we know that the expression for dy by dx. So I can say that y is equal to 7 minus x divided by 2x plus 3. So dy by dx will be equal to, we can see that we cannot simplify this expression. As we cannot simplify this expression, we have to use the quotient rule for differentiation in order to differentiate this function. So this will give us 2x plus 3 as the numerator. Following the quotient rule, we get that the denominator will be squared. So 2x plus 3 is squared here. Then we will multiply 2x plus 3 with the differentiation of 7 minus x, the numerator. Then I will subtract 7 minus x and multiply the differentiation of 2x plus 3 with it. So this will give us 3x plus 2x plus 3 into the differentiation of 7 minus x is equal to 0 minus 1. So minus 1. Minus of 7 minus x into the differentiation of 2x plus 3. So 2 into 1 plus 0. The differentiation of 2x plus 3 is 2 plus 0. So 2. So this gives us 2x plus 3 whole square. We get minus 2x minus 3 if we expand our first term. And then we will have minus 14x plus 2x on our last term in the numerator. This will have a denominator of 2x plus 3 whole square. Upon simplifying, we see that minus 2x and plus 2x they cancel off, and we have minus 17 by 2x plus 3 whole square as our answer for dy by dx. So we see that we have an expression for the dy by dx. We know that the value of dy by dx is our gradient at any single point of our curve. So if we use the x coordinate of a into our expression, we will get the gradient of our curve C at our point A. So I can use the x coordinate of point P. At point P, x is equal to half. So the dy by dx, or the gradient, will be equal to minus 17 divided by 2 into half plus 3 whole square, and this is equal to minus 17 by 4 square, or 16, and we have shown this. We can see that the value we obtained is the same value given in the question. So we have shown this. So this concludes our part C. Part D. For part E, it is given that C also passes through the point P. So there is another point P through which our curve C passes through. Now it is given that the tangent to C at point P is parallel to the tangent to C at point A. As the tangent at point P and the tangent at point A are parallel, they have the same gradient. They will have the same gradient. In part E, we have to find an equation of the tangent at P. In part E, our question is that we have to find out the equation for the tangent at point P. In order to find the tangent at point P, we have to know the gradient of the tangent, and we also have to know a point on that tangent. we already know that the gradient of the tangent will be equal to the gradient of the tangent at point A. So as the tangent at point P and the tangent at point A have the same gradient, I can use the value of the gradient at point A to write out the gradient of the tangent at point P. So I can write for part E, I can write that the gradient of tangent at P is equal to minus 17 by 16. Again, the reason for this is that the gradient of the tangent at point P is equal to the gradient of the tangent at point A. As they're parallel, their gradients will be equal. And as the gradient at point A is minus 17 by 16, the gradient of our tangent at point P will also have minus 17 by 16 as its gradient. From this, we can also say that our point P will have the gradient of minus 17 by 16. So I can use my expression for dy by dx, and I can use this to find out the x-coordinate of P. So I can write dy by dx is equal to minus 17, and then I can use my expression to find out the values for which minus 7 by 16 is a gradient to our curve. This will give us 2x plus 3 whole square is equal to 16, or 2x plus 3 is equal to root over plus minus root over 16. So 2x is equal to minus 3 plus minus 4, or x is equal to minus 4 plus minus 4 divided by 2. If we evaluate this, we get 4 plus minus 3 by 2, which is half, and the other value would be minus 3 minus 4 divided by 2, so minus 7 by 2. These are the two values for which the gradient of our curve C will be equal to minus 17 by 60. We can see that x equals to half is the x coordinate of our point A. So from this, I can deduce that minus 7 by 2 is the x coordinate of our point P. We can say that the x coordinate of our point P is minus 7 by 2. I can use this x coordinate to find out the y coordinate of our point P. So we know that y equals to 7 minus x divided by 2x plus 3. Using our value of x, we get 7 minus of minus 7 by 2 divided by 2 into minus 7 by 2 plus 3. This will give us 21 by 2 divided by minus 7 plus 3, which is minus 4. So ultimately we get minus 21 by 8. Now we can find out the equation of our tangent. We know that in order to find the equation of any straight line, we need to find the gradient of that straight line, and we need to have a point on the straight line. In our case, we have the gradient of our tangent, and we also have a point on the tangent. The point on the tangent is point P. We now know that the point P has coordinates minus 7 by 2 and minus 21 by 8. So I can write that equation of the tangent at P is equal to y minus y1 equals to mx minus x1. So m की minus 21, I'm sorry, m is equal to minus 17 by 16. As the two lines as the two tangents are parallel, the gradient of the other tangent will be equal to the gradient to this tangent. So m is equal to minus 17 by 16, and the point we have is minus 7 by 2 minus 21 by 8. Now I can use these values to find the equation. So minus 17 by 6 x minus of minus 7 by 2. So y plus 21 by 8 is equal to minus 17 by 16x plus 7 by 2 into, so plus 7 by 2 into minus 17 by 16. Now what is left to do is simplification. We can multiply both sides of our equation with 32. This gives us 32y plus into 84 equals to minus 34x minus 190. We can bring all the terms to the left side. So 32y plus 34x plus 84 plus 190 equals to 0. Ultimately, we get 34x plus 32y plus 84 plus 119, which is equal to 203. This is our equation for our tangent, and this is our answer to part E. And this concludes our question number 10. We can now move to question number 11. This is our question number 10. We can see that in part A, we have to show that cos to the power of 4 theta minus sin to the power of 4 theta is equal to cos 2 theta. We can see that in this expression, we have cos to the power of 4 and sin to the power of 4. This can be written as cos square theta whole square and sin square theta whole square. Our equation can be written like this. The reason we are writing this our first line like this is because we want to apply the expansion for a square minus b square in our expression, in our equation. So writing like this enables us to do this expansion in our expression. So now I can see that I can write cos square theta plus sin square theta into cos square theta minus sin square theta is our simplified expression. Now from here I can see that this expression will be equal to 1. We know the identity that sin square theta plus cos square theta is equal to 1. I can use this identity to simplify this expression. So we know that cos square theta plus sin square theta is 1. So this term will be equal to 1. Now for the other term, I know that the double angle formula for cos theta, which is cos 2 theta, is equal to sin square theta minus cos square theta minus sin square theta. The double angle formula for cos theta is equal to cos square theta minus sin square theta. I can use this identity to write cos square theta minus sin square theta as cos 2 theta. Doing this will clearly show that sin to the power of 4 theta minus sin to the power, cos to the power of 4 theta minus sin to the power of 4 theta is indeed actually equal to cos 2 theta. So we have shown this. We have shown that this is true. So this completes our part A, and we can now see part B. In part B, we have to use the part A, or otherwise we have to solve the equation 8 cos square 2 theta plus pi by 4 minus 3 equals to 2 cos to the power of 4 theta plus pi by 8 minus 2 sin to the power of 4 theta plus pi by 8. To solve this equation, I will first write out the equation. So 8 cos square 2 pi plus 2 theta plus pi by 4 minus 3 2 theta plus pi by 4 minus 3 is equal to 2 cos to the power of 4 theta plus pi by 8 minus 2 sin to the power of 4 theta plus pi by 8. On our right hand side, I can see that 2 is a common factor in both of these terms. So I can take 2 common, and this will give me cos to the power of 4 theta plus pi by 8 minus 2 sin to the power of 4 theta plus pi by 8. We can see from here that this expression is exactly similar to our part A, to the expression in our part A. So I can simplify this expression by using the simplification in our part A. So we know that this expression would be equivalent to cos 2 theta. We have to notice that theta in this context is theta plus pi by 8. So we are writing that. So theta in our context is equal to theta plus pi by 8. Now we just have to simplify, and this gives us cos 2 theta plus pi by 4.
and we know the right hand side is equal to 8 cos square 2 theta plus pi by 4 minus 3. Now I can bring all the terms to the left. So 8 cos square 2 theta plus pi by 4 minus 2 cos 2 theta plus pi by 4 minus 3 is equal to 0. Now I can see that this forms a quadratic equation, and I can solve the quadratic equation to find out the values of cos 2 theta plus pi by 4. So to solve this, I can uh, I can assume that a is equal to or cos 2 theta plus pi by 4. This is just for simplification purposes. So this gives us 8a square minus 2a minus 3 equals to 0 as our expression, and we can see that this is a quadratic expression, and this can be factorized using the middle term method. So we can write 8a square minus 6a plus 4a minus 3 is equal to 0. Now we can take 2a common from the first two terms, and this will give us 4a minus 3 inside our brackets, and then we can take 1 common, so 4a minus 3 again in our brackets. So we can simplify this as 2a plus 1 and 4a minus 3 equals to 0. So from this we can see that ultimately 2a plus 1 is equal to 0, or 4a minus 3 is equal to 0. So a is equal to minus half, or a is equal to 3 by 4. We know that a is equal to cos 2 theta plus pi by 4. So I can write that cos 2 theta plus pi by 4 equals to minus half, or cos 2 theta plus pi by 4 equals to 3 by 4. So from this we get that 2 theta plus pi by 4 is equal to cos inverse 1 of half, or we get 2 theta plus pi by 4 is equal to pi by 3. We have excluded the sign when calculating the cos inverse 1. The reason for this is we are finding the basic acute angle. Now we can see from here that as our value of cos 2 theta is negative, 2 theta plus pi by 4 will exist. I can say that 2 theta plus pi by 4 exists in the second and the third quadrant. So now I have to find the values of 2 theta plus pi by 4 in our range given in our question. If we see the question, we can see that the range given is theta is greater than 0 but less than pi. So theta is greater than 0 but less than pi. We can see that the range given is for theta, but we need to find the range for 2 theta plus pi by 4. So in order to adjust this, I can multiply the whole every part of our range by 2. So this will give us 2 theta is greater than 0 but less than 2 pi. Then I can add pi by 4 to every single part of our range, and this will give me pi by 4. 2 theta is greater than 2 theta plus pi by 4 is greater than pi by 4, but less than 2 pi plus pi by 4. And this is our extended range, and we have to find our value of 2 theta plus pi by 4 within this range. We can see that the basic acute angle for this particular expression is pi by 3. We know that 2 theta plus pi by 4 exists in second and third quadrant. So in order to find the angle in second and third quadrant, I have to subtract our basic acute angle pi by 3 from pi, and this will give me the angle in the second quadrant. For the angle in the third quadrant, I have to add pi by 3 to pi, and this will give me the value in the third quadrant. We know that we know that in the out of the four quadrants, the first quadrant gives us all the positive values, the second quadrant is positive for sine, the third quadrant is for tan, and the fourth quadrant is for cos. So there are two values of 2 theta plus pi by 4 within our range. Any other value will be out of the range, so we will not consider that. Simplifying this gives us 2 by 3 pi and 4 by 3 pi. So 2 theta plus pi by 4 is equal to 2 by 3 pi and 4 by 3 pi. From this I can find out theta. So 2 theta is equal to 2 by 3 pi minus pi by 4 or 5 by 2 of pi. For the other value, 4 by 3 pi minus pi by 4, 13 by 2 of pi. Ultimately, theta is equal to 5 by 24 pi and 13 by 24 pi. 13 by 24 pi. Now for our second expression, we can solve it down here. So we can write that cos 2 theta plus pi by 4 is equal to 3 by 4, and we can find out the value, the basic acute angle for this expression, which is cos inverse 1 of 3 by 4, and this gives us 0.7227 as our basic acute angle. I can observe that cos 2 theta plus pi by 4 has a positive value. As this has a positive value, the angle must exist in the first and the third quadrant. Sorry, in the fourth quadrant. In the first and the fourth quadrant. So we have to find the values of angles that are in the first and the fourth quadrant within our range. So 2 theta plus pi by 4 is equal to 0.7227 because this is within our range, and we have to find that the fourth quadrant value, which is 2 pi minus 0.7227. And these are the values for our 2 theta plus pi by 4. So I can write that 2 theta will be equal to 0.7227 minus pi by 4, and we can write that 2 pi minus 0.7227 minus pi by 4 will be our other angle. From this I can find the value of theta. So the value of theta would be so now we can write 0.7227 because it is in the first quadrant. I can also find out the fourth quadrant value, which is 2 pi minus 0.7227. I can also put in the first quadrant value, which is 2 pi plus 0.7227. If I see the range for a moment, I can see that 2 theta plus pi by 4 is greater than pi by 4. Pi by 4 is equal to 0.785. And we see that 2 pi plus pi by 4 is equal to 7.0685. So from this I can clearly see that as our range is greater than 0.785, we cannot have 0.7227 as a valid angle. So this is not applicable. So the other two can be applicable because the other two will be within this range. So now I can simplify 0.7227 and 2 pi plus 0.7227. This is equal to 2 theta plus pi by 4. So theta would be equal to 2 pi minus pi by 4 minus 0.7227 divided by our value of 2. And this and for the second one we have 2 pi minus pi by 4 plus 0.7227 divided by our value 2. And this will give us 2.39 and 3.11 as our value. So from this we can see that theta is equal to 4 values: 5 by 4, 24 pi, 13 by 24 pi, and 2.39 and 3.11. These are the 4 values for theta, and these are the solutions for theta. So this gives us as a solution of our part B. For part C, we have to use calculus to find the exact value of this integration. We see that this is an integration of cos to the power of 4 2x minus sine to the power of 4 2x minus 8 sine of 4x. So for part C, in order to differentiate our expression cos to the power of 2x minus sine to the power of 2x minus minus 8 sine 4x, I can simplify this expression before integrating this. Again, we can simplify this using our simplification in part A. In part A, we saw that this expression can be simplified to cos 2 theta. So in place of theta, we now have 2x. So the simplification would be cos 2 into 2x minus 8 sine 4x. Again, this can be simplified. So cos 4x minus 8 sine 4x is our simplified expression that we need to integrate. So if we integrate this, cos 4x minus 8 sine 4x dx, and the limits given is pi by 8 and pi by 16. Now we can simply integrate this. The integration of cos 4x will be sine 4x divided by the differentiation of 4x. The differentiation of 4x is 4, so I'm dividing by 4. Then we have minus 8 into the differentiation of sine 4, the integration of sine 4x. The integration of sine 4x is minus cos 4x divided by the differentiation of 4x. Again, the differentiation of 4x is 4, so I'm dividing by 4. I can then write the limits and pi by 16. If I simplify this expression, we get 1 by 4 sine 4x minus 2, plus 2 cos 4x. We now just have to put the limits and calculate to find the value for this integration. Now I can now input the values. 1 by 4 sine 4 into pi by 8 plus 2 cos 4 into pi by 8 minus 1 by 4 sine 4 into pi by 6 16 plus 2 cos 4 into pi by 16. Now upon simplifying this, we will get 1 by 4 sine pi by 2, which is half. Sine pi by 2 is equal to 1. So sin pi by 2, which is equal to 1, and then we have plus 2 cos pi by 2, which is again 0. Then we have here 1 by 4 sin pi by 8, pi by 4, I'm sorry, pi by 4, which is equal to root 2 by 2. So root 2 by 8, and then we have 2 cos 4 into pi by 6, 4 into pi, so root 2. Ultimately, from this we get 1 by 4 minus root 2 by 8 minus root 2, and we can simplify this as we can write this as root 9 by 2 divided by 8. This can also be written as this. If you see the question, we have to give your answer in this form: a minus b root 2, where a and b are rational numbers. So our answer must be in the second form. And this is our answer. This is our answer to our part C. And this concludes our question number 11. And this was the end of our paper. Thank you for watching. Subscribe to our channel for more contents like this.